Hello, calculus scholars. Today we're going to do skill 31, which is inferences using tables from some pretty well-known calculus theorems. So just a reminder what we mean by theorem. We kind of think of that as a general proposition, not self-evident, but actually proven by a chain of reasoning, a truth established by the mean of accepted truths. So what I mean by that is that they're kind of definitions that have been proven. If you actually want to go through, the act of proving them, you can actually take advanced calculus, which is also called analysis in college. But what we are going to do is just kind of like use and analyze some definitions. So one thing that I will say that is important is that the definitions today that we are going to assume is continuous and differentiable. So these two conditions must be met. So what this means is that if you have a function for which you cannot take the derivative because maybe it's not continuous at a certain x value in the interval, there's actually no way that you can use like some of the definitions that we are going to be developing. So I want to kind of go through the major definitions and also show you what they look like on the delta math as well. All right, I'm going to warn you that these theorems appear to be kind of dry and dense, but what I did is I bolded important things. So the intermediate value theorem states that if f is a continuous function, so what that means is if there's no mentioning that f is continuous, you can't use it. So must be continuous. Whose domain contains the interval a to b in closed bracket. So as long as the point of discontinuity does not occur in your interval, you are kosher to use the intermediate value theorem. Then it takes on any given value between f of a and f of b at some point in the interval. So here's an example. Let's say I'm actually just going to kind of make a weather example. So let's say at 6 a.m. and I'm kind of being a little bit crude here. So I'm kind of putting like time and temperature. Because I want to kind of make this, relevant. And let's say, at 6 a.m. it is 65 degrees, and at 5 p.m. it is 85 degrees. And maybe the temperature goes like that. So what that means basically is that by the IVT, what that means is that we must hit every temperature between 65 and 85 between 6 a.m. and 5 p.m. So for instance, we must at some point hit 70 degrees. We must at some point in that interval hit 75 degrees. Now, we're not guaranteed to have 60 degrees though. So that's what we mean by the intermediate value theorem. So let's take a quick look right now at a intermediate value theorem question. All right, so this is example 1. So this is a intermediate value theorem question. So I'll just call this example 1. And it says selected values of the continuous function f. So we are good, we are continuous. If it says not continuous, then there's really no way that we can kind of continue. And it's actually automatically kind of a false statement. It is known that f prime of x is greater than 0. So this means that f of x is increasing. Determine the following statement, that f of x has to equal 0 has exactly one solution in the interval 3 to 8. So what that means here is it's constantly increasing. Constantly. So that means, like, if I'm graphing and I have three, here's 8, and I'm like at 3 comma negative 8, and I'm just kind of being a little rough here. And then this is 8 comma 16. We are looking for where we want f of x to equal 0 at some point in that. And I'm just going to get a different color here. So it's asking us, is there just one solution? Let's actually try this out. So I'll choose like blue. So obviously I do have to cross 0 as long as it's continuous at some point. So this is kind of your straight shoot way. So that's one solution. That's also one solution. Now let's say that I want to have more than one solution. So I'm going to try to have, maybe 2 solutions in that interval. So maybe I'll do the yellow line. Now notice there, if I already crossed 0, then I have to go down again. So it says determine the validity here. So it seems to me that there is exactly one solution because it is continuously increasing. So it's continuous. It's also increasing through the entire interval. And we have gone from like negative 8 to 4 to 16. Now I encourage you, when you're doing this exercise, that you actually read the theorems. They actually practice explaining it in terms of the theorem itself in kind of a very precise language, and even kind of guide you through the logic. So if you get a problem wrong, then I think it is good practice to kind of test your logic and compare it with the logic on Delta Math. All right, let's look at another problem here. It says selected values of the continuous function are shown in the table below. So far, so good. If it does not say continuous, you're pretty much done for false, or like could not necessarily be true or false. And it says determine the validity of the following statement. So it says f of x equals 0, has exactly one solution in the interval 2, 7. So this is a little bit different than the last example. So call this example 2 here. So what's different here is we have no rule about increasing or decreasing. So like, let's say, this is like, 2, 9, and this is, like 5, -3, and 7, -15. And let's suppose that, could I fit a curve that has like more than one solution on there? So I'm going to kind of like draw the yellow curve, and let's kind of see what happens. So, maybe, just maybe, I have a situation like that. It actually has more than one solution, and we're not violating, the terms and conditions on there. It is a possibility. Maybe we are, continuously going down. But it's also a possibility that maybe we're going down and then up and then down again. So it kind of leaves it a little bit more open. So the statement could be, true or false. Now, obviously, you get to really interesting things if there's not the continuous assumption. So if there's not the continuous assumption, then you're going to be in the land of falsehood. So this is the intermediate value theorem, and stay tuned for the next 2 theorems that we will do in separate videos.